All right, this is the last part of Chapter 1's notes. Again, please make sure that you're copying down as much as you can, because the more you write down about what we're doing here, the better off you're going to be prepared. Not only for the notes quiz where you get to use your notes, but also for the test where you don't get to use your notes, but this information is the part that you need to study. So we just talked about the scientific method. So you've gone through and you've talked about, well, you've got a problem, you do some background research, you come up with a hypothesis, an educated prediction. You have to test that hypothesis with an experiment. You have to look at the results, come up with a conclusion, whether your hypothesis was right and you have evidence to now show that it's right or not. Okay? So there's a few other words that come into play when we start talking about things like the scientific method besides hypothesis. And that's the word theory and the word scientific law. And a lot of people get these three mixed up. And in some cases, some people think that they just mean the same thing. And they are not anywhere close to the same thing. There is some relationships between them, but they are definitely not the same thing. Let's start with hypothesis. You guys already know this, but the hypothesis is the educated prediction to an answer or a question, okay? So you know that we're not talking about a guess here. It's a prediction because you're seeing if you're right or not by doing then the experiment. So let's do an example. Let's say that you have always been curious about gravity. Right? A lot of people don't think about it, but let's say you're curious about gravity and you're wondering what causes it. You know it's here. You know it's what keeps your feet to the ground, but why? What causes it? So let's say you do some background research and you start reading up on different forces of nature and you realize that the other forces of nature that we have identified in science all have little tiny particles that cause them. For instance, light is always caused by tiny little particles called photons, right? So there's always tiny little particles that go along with forces in nature. And so let's say that you come up with a hypothesis and you say, I think gravity is also caused by tiny little particles because that's what most other forces of nature are caused by. Right, so that's a hypothesis. You have no clue whether you're right or not until you start going through and doing experiments about that. So let's say that you do some experiments on this and you start to find that there's evidence that you're correct. Now you don't stop there. So now you start to tell other people, so other scientists, and you say, I've been doing these experiments on gravity and I've found some evidence, and you show them and they say, well, that's interesting. Let me do some experiments of my own on this and see if we're kind of on the same page here. And then they start doing experiments and there's lots of evidence now being collected by lots of different people over the same subject. Eventually, if there's enough evidence to show that that prediction is correct, we then are going to change that hypothesis into a theory. So a theory is an explanation based on a lot of testing. So if you have a theory, it's already something that has a lot of evidence to show that it's correct. It's not some kind of guess. It's not like a hypothesis which comes before the experimentation. It comes after. Well, it turns out that there's already a theory of gravity out there because there already have been a lot of experiments done on gravity. And yes, there actually is lots of evidence that shows that they are caused by tiny little particles. They have actually been called gravitons. Right? So we have a lot of evidence that now shows that, and so now we would call that a theory of gravity because it explains how gravity works, okay? So a hypothesis can turn into a theory after many, many experiments are actually showing evidence that it's correct. Scientific law, totally different, okay? Scientific law has nothing to do with explaining something. It is simply a fact of nature. It is simply just somebody's been observing something over and over and over again, and eventually we just kind of write it down as this is the way life is. So there is a law of gravity. You've probably heard this one before. Law of gravity goes something like this. What goes up must come down. It doesn't try to explain why that happens. It's just an observation that people have made over and over and over again through the years. And we finally have just chalked it up to, that's the way the world works. Right? And then, of course, people after that started going and making hypotheses about how gravity works. And eventually we came up with a theory about how gravity works. But the law part is simply just a fact. What goes up must come down. Right? No explanation to it. So keep those three in mind, because we talk about all three of those, and sometimes people kind of mix them up. You probably have noticed this a lot. If you watch television and movies, and somebody comes and says, you know what, I have a theory about how this happened. No. They're actually using that word wrong. A theory comes after you've already collected the evidence. But if you don't have anything to show that you're right, at that point, it's just a hypothesis. But for some reason, the movies don't like that word, and they always like to use the word theory all the time. All right, the one other thing that we're just going to briefly cover for now, and we'll get much more into this when we get into Chapter 3, which is the next chapter we're going to go to, is problem solving in chemistry. Now, problem solving in chemistry is problem solving really anywhere, because this isn't unique necessarily to just chemistry. If you want to solve any kind of problem, and it doesn't matter where and how, but if you want to solve any kind of problem, obviously you need to develop some kind of plan to do that. And a plan to solve a problem generally involves three things. You need to analyze the problem to begin with, right? You read through it. You look at what kind of information in there is important. What kind of information is it asking you to find? Maybe you know of some kind of mathematical way of doing it. And then you'll need to calculate the answer to that problem. So you'll need to take that plan, you'll need to put it in place, put the numbers in, and calculate what the answer is. And then the part that most people forget about, when you're solving a problem, you should always evaluate your answer at the end. Right? So let's say we're solving a problem about how much area is the floor of your bedroom. Because you may be sitting there right now, and you're looking around your room, and somebody asks you, how many square feet is your bedroom floor? Well, you may already know how to solve that problem, right? You'd have to do a couple of measurements, a length and a width of your room, and then you'd multiply them together, and then you would get the square footage of your room. So let's say that I asked you to calculate the square footage of your room, and so you did some measurements, and then you multiplied, and you got your answer. And let's say you came up with 2 million square feet, right? I think all of us right now would know there is a problem with that. Right? Nobody lives in a room that's 2 million square feet. That doesn't make any sense. It's possible that you did get that answer, but it's probably because you accidentally typed a number into your calculator wrong, or you didn't do the math exactly right. So evaluating your answer is important, because if you just blindly put that answer down, everybody else is going to see that as ridiculous. Even you would if you really looked at it. And that's going to happen this year. You're going to come up with some answers on things, and you may at times look at that answer and going, there's no way that could be right. And so you need to do the evaluation at the end also. Okay, there's chapter 1. It's just the introduction to some things that we're going to be covering in here. All of this information is going to be on the test. So this is information that you've taken notes over and you should be studying at this point.